Hey guys, we had a very popular podcast some time back with Dr. Barrie Tan, a lovely gentleman of extraordinary knowledge and research. And he did a PhD in New Zealand. He was a professor at the University of Massachusetts, I think. But today we're going to talk about GG, and it's a compound that could have great importance, an endogenous compound. And it follows on from Dr. Barry's work on tocotrienols, which we talked about last time. So great to see you again, Dr. Tan.
Thank you, Ivor. This is a pleasure. Thank you. And this is a pleasure to come back on. And I know your audience is far and wide. And hopefully, this will be a stunning addition to what we already know about the unusual vitamin E tocotrienol we spoke about some time ago last year.
Yeah, absolutely, and it's great to be back. And this compound I was not familiar with, and I'm still not really. I might get you to pronounce it. I know it's GG, but we'll get the correct pronunciation.
GG is geranol. So it's actually two molecules of geranol together, geranol. And while we're at it, I might as well show the audience. This is a small segue. I know it's only a pictorial thing. This is what they call a ball model. This would be an example of the vitamin E tocotrienol. And this is the antioxidant, had the red one, has a ring system. And you see the tail here, from here onwards, all the way down here, that tail is part of GG, except people don't talk about them. So now, if you remove the ring here, this would be the structure of GG. So this is called a terpenoid. The tail is exactly like that on the tocotrienol. It does have an alcohol, but this alcohol here is not an antioxidant because it does not have a ring system. This molecule is one of the substance of life. Hopefully we can delve into this. I look very much forward to talk about this endogenous nutrient.
Great stuff. And actually, while I'm thinking of it, Barry, we might do a quick recap on the tocotrienols because I was familiar before our podcast of vitamin E and it's very important, and the tocopherols, but maybe a little recap on the importance of the tocotrienol variant of vitamin E specifically, because that kind of led to the learnings around GG that we'll go through today.
I worked on tocotrienol probably about 35 years ago. I first discovered it from palm. And then I discovered tocotrienol. By that time, everybody know about tocopherol. And then I discovered it from rice. In rice and palm, it contained 25 to 50% as tocopherol. And we found that with tocopherol, it antagonized the function of tocotrienol. So therefore, all these years of research that I have from palm and rice did not go further because it contained 25 to 50% tocopherol. It's part of the whole thing. So I couldn't do anything until about 3 years ago, I happened to be in South America. That for me is actually, I would say, a personal epiphany, a spiritual moment. Being a Chinese, you can see me. You would think that I would go to Asia. There are many things, proliferating things like that, but that's not where I went. I went to South America. I can't speak a word of Spanish. I went there to look for lutein. And unbeknown to me, I found a plant called annatto. This is a beautiful picture of annatto here. See that? And that's a color. And it was discovered by the French conquistador Francesco de Orellana, and hence the scientific name is Pixa orellana. 150 years ago in the Amazonia, the British also found this, and the British nicknamed it the lipstick plant because of the beautiful red color, like that. And it's definitely an Amazonia plant, because if you look carefully, this is a picture. If you look at the frog, there's a tree frog. The whole tree frog is about the size of a US penny. So it's very small, like that, just to let you know it's from Amazonia, where these tree frogs are found. It is a plant known to antiquity. This is a picture of my discovery. You can see a very young me, long time ago, and on a plant there. And the Inca Indian used this to color and decorate their position in life. The last one, and a young Inca child dressed his head with this so that because the insect repellent and is also an antioxidant to protect them because they may not able to wash their body every time for protection. So it's been known for antiquity.
Oh, yeah. And the beauty of the annatto plant or the bean was that it naturally had a very high concentration of tocotrienols without the potentially antagonistic tocopherol element of vitamin E. So it's just nature delivered a beneficial compound.
That is true. And thank you for helping me to get there. So I actually went there to look for a carotene. And then I found this plant. I'll tell you simplistically. I deliberately put this in 4 test tubes. I'm going to go closer. If you see, the middle 2 test tube is bleached out, is brown color. And the 2 end ones, you can see the carotene there, and the end ones and the carotene there. All this to say, the tocotrienol is so able to protect the color, and the color will not bleach. That's it. So when I first got this, I did not know much more than that. And then when I analyzed, I thought it was a polyphenol. And when I analyzed, I said, oh my God, this is completely free of tocopherol, contain the only 2 tocotrienol, which is delta tocotrienol and gamma tocotrienol. If the audience go to search on the internet, delta tocotrienol and gamma tocotrienol, I do not control this information. You'll find professors and scientists all over the world, they study them, and they mitigate chronic conditions. That would be, for us and other people, chronic conditions like cancer, some of them very serious, cancer, fatty liver disease, we covered it the last time, lipidemia, we are also studying now in Texas, postmenopausal women with obesity. Definitely chronic condition. So we have all these studies out there for tocotrienol. So you would have guessed, if I did that, that would be a home run for me. Yes, it is a home run. More so, not so much I would make money, more so that people would benefit from them like this. But who would have guessed? When I extract this from this annatto seeds here, you can see closer the annatto seeds there. Who would have guessed? After I got them, I extract them, I got the oil out, I removed the color vixen, the British call it the lipstick plant, and then I found the antioxidant with the tocotrienol. I found something that is light yellowish color that isn't what I have eliminated, not the tocotrienol and not it. And then I found out that compound is geranylgeraniol. Simplicity, we just call it GG. That's it. So with that, I like to use this as a metaphor, and then you can pick up. I thought that there's a dog, and a dog has a tail. I always thought that when I first discovered it 4 years ago, Ivor, that I now am studying tocotrienol, which is a dog. I cannot spend enough time, effort, and resources to study GG. I know someday the tail would wag the dog. And today is that day. The tail is wagging the dog. The tocotrienol is still stellar, but you're the first. And I want to remind the audience who listen to you, this is the first time I'm entreing to the public space about the value, the meaning. I'm looking so much forward to explaining. So tell me more about this, Gigi. I'm also searching more. So to the extent that I know, I'll pass on to you. And if there's anything I don't know, I'll also let you know about this tail that wags the dog.
Excellent. I love the analogy. And that often happens in science as you find a beneficial compound and then you discover later on that there were sub-elements within it that were really I don't know, having the effects that you thought the overall molecule did. So there's a lot of precedence for that. But for people as well, I don't like to have pride of authorship here, but I think our interview is the best possible introduction to tocotrienols generally. So I'll put the link below. And with that, we'll get into this GG compound, or the tail that is wagging the dog. And I'm inferring now that the GG element of tocotrienol is having a very active role, maybe a dominant role. And interestingly, it's also endogenous. So the mevalonate pathway that we associate with cholesterol synthesis and statins, that this GG is actually part of that pathway and is generated by the body for various biochemical uses. So I love when things from nature can be taken and they mirror what the evolved human machine has already decided to synthesize. But anyway, I won't go on. Let's get into this, GG.
You put it beautifully. In the human body, if I can find that thing, I will bring that up. You only take one. Okay. This would be an example of a mevalonate pathway. If you look on this, the pathway indicate where the cholesterol would form. Right below the word farnesol, there is geranylgeraniol. So it's right there. And with geranylgeraniol here, you can see it make all the things here. I'm hoping to cover them. Now,
excellent. And many viewers will, in my world, are somewhat statin skeptics, which I think is very fair, concerned around impacting this pathway, CoQ10 and, cholesterol synthesis. And, this is really interesting that GG, this new story emerging, is tied right into that whole nexus.
Oh, wow. I did not know that. Then let's address that face on. I make no assumption that the audience is in favor of statin for cholesterol reduction or not. I'm just bringing out the fact. And if I were to have high cholesterol, isn't this interesting? As we age, the endogenous nutrient in our body usually decrease, with only one exception. The endogenous nutrient is cholesterol. So therefore, even if we say yes or no to lowering cholesterol, we should grapple with the fact that with age, all the endogenous nutrient in our body drop. Actually, with except two, cholesterol and sugar. And it's obvious to our audience why these two. And I struggle with it myself too. Why do we have hyperglycemia and why do we have hypercholesterolemia? So now, let's take the statin thing, because the statin is probably one of the most well-studied. Now, on the GG thing is ironic, and life is never sometimes straightforward. But I try to encapsulate in a picturesque manner. If it weren't because of statin, people probably would not be studying the mevalonic acid pathway. And if people were not to study the mevalonic acid pathway, probably I would be ignorant of GG. But because people use statin to inhibit the mevalonic acid pathway, think of it as an isoprenoid pool. So when you add a statin here, earlier on here in the mevalonate, it stopped the reaction. So one step below, all the cholesterol drop, presumably desirable, but it stops there. And then further down is GG. People don't address that. It was only addressed because when people take statin, one step to lower cholesterol, they like that for the people who take statin. So I'm not pushing people to take statin. But then when people take statin, the first thing that they notice in our nutritional supplement industry was, hey, your CoQ10 dropped. That's not good for the heart. So they figured that out. So our industry then, if you take statin, you better supplement CoQ10. So some understanding was brought back. And then when people take statin, the cardiologist said, not the nutritional supplement, Well, Mrs. Jones, I am bothered that you have muscle pain and back pain. See, that's not really a CoQ10 thing. So they have myopathy, myalgia. So that left a question mark. What is this that can help us understand if you take statin to lower cholesterol and then CoQ10 drop and then myopathy, which is protein synthesis, drop? Before I answer that question, Ivor, if your audience get this, you are the smartest people. In the last 5 years, scientists also found if they take statin, they could have osteopenia and osteoporosis. And also they could have arteriosclerosis and even kidney stone. If you combine them together, the calcium is not put where it should be in the bone, osteoporosis, and the calcium is put in soft tissue that we don't want, like the artery, like the kidney, like the biliary gallbladder. We don't want calcium there. That is the vitamin K2 part. So I am saying to your audience and to you, the reason for CoQ10 drop, the reason for myopathy, and the reason for calcium put in the wrong place, they are all because statin drug inhibit the synthesis of GG in the human body. If you got that, that is the best endogenous nutrient we could ever imagine. And that is encapsulated entirely in this chat. I hope that you can bring this to your audience. You can see there in the bottom, all of those I mentioned. And they all have to do with when we use statin to inhibit the mevalonic acid pathway to lower cholesterol, indiscriminately, I will use that word, indiscriminately statin also inhibit GG, and with the consequence of inhibiting GG, CoQ10 drop. Why? Because GG is required for the synthesis of CoQ10. And myopathy happen, skeletal muscle, because all skeletal muscle required GG for the synthesis of skeletal muscle. And calcium is put in the wrong place. Why? Because this is so, I love this when I discovered this about 2-3 years ago. GG is required for the synthesis of manoquinone 4. Would you believe that? without GG, we cannot have manoquinone 4. And I'm sure your audience knows about manoquinone 7 that the bug makes. Correct. All the manoquinone 4 to 13 long tail are made in the gut. Only manoquinone 4 is made in the human body, not by fermentation, by biochemical processes. So if I were to be a person care for my health, I would definitely beg to ask the question, of all the manoquinones, why does the body, through the evolution of time, only make MK4 in the human body? You should interview many other famous scientists. Why MK4 is made in the body and why all the other MKs are only made in the gut, and most of them are not absorbed because by the time you get to the colon, it's already past the small intestine window. So they're not absorbed. So in the colon, pardon me for saying that, is the making of poop. So only moisture is absorbed, not nutrient. It's already, and that is where the MKs are made. But then they're not absorbed mostly. So you have to supplement. And the thing that people supplement is MK7. So you quickly bypass that. So I'm appealing to the audience. I just explained to you, your precious GG in your body is making MK4 in at least 25 organs and tissue in your body. published by Japanese scientists. Once we know what this MK4 does in the body, then a whole new vistage and a world of understanding of GG will emerge.
Oh, there's a lot to unpack there for sure, but certainly many listeners will resonate with this whole calcification and pathway that we discussed there. And that does bring together a lot of different questions. It's acknowledged now that the statins cause in 20 to 30% of people overt symptoms of muscle pain, etc., and associated issues. I wasn't so aware of the osteopenia, etc., but certainly the calcification and the tendency to calcify through antagonism of K2 generally has been published on. But I think there you've brought it all together into kind of all those different elements go back to a common kind of central point of the GG production, which is upstream and required for all of these different pathways or vectors. So that really ties things together for people. And, you know, consequences, unintended consequences, whatever drug has a beneficial effect, it has to also be poisonous at some level if it's going to have an effect. Now, that's natural substances can be kind of all good, but drugs generally, they disrupt pathways, they interfere, and they've got a pro and a con. So here, the statins have a lot of cons, and then you can debate about the pros, the benefits of some anti-inflammatory, kind of pleiotropic nature, perhaps lowering the cholesterol lowers the damaged cholesterol particles, so indirectly do cause some benefit. But it's kind of like pro and con are all mishmashed together. But sorry, we'll get back to the GG and how this endogenous component, if you are taking statins, you're going to want to boost it somehow to counteract the problem. And if you're not, you're going to tend to want to maximize it regardless.
Yes, on the second point that you made, what if I don't take statin? What would be the meaning of GG for me? I think that is a good question. I'm not, once again, I am not pushing yes statin or no statin. Say no, a person is not taking statin because they don't have hypercholesterolemia. So what is the meaning of that? The meaning never goes away because your body produces GG. So if I will be, regardless if I have hypercholesterolemia, I want to know, what does the body produce GG for? It will be the same thing I said earlier. The GG is in your human body to make CoQ10. It's in your human body to make skeletal protein. In your human body to make MK4. Let's take that a piece at a time. Making GG, making CoQ10. What is CoQ10 for? CoQ10, thanks to a British, Peter Mitchell, he got the Nobel Prize in 1978, unequivocally confirming CoQ10 is required in the mitochondria to produce the currency of energy called adenosine triphosphate. In other words, we take food, it must convert to a currency, and that cannot happen without CoQ10. And the active form of CoQ10 is ubiquinol. That's it. So you have to do this. So I did not say anything about statin. So you have to do this. But as we age, our ability to make CoQ10 drop. And therefore our energetics is lowered. One. The second one, skeletal, muscle, and protein. I'm not talking about myopathy. As we age, we have seen people in nursing home, and we can tell, and also our older parents. So when we have a nursing home and older parent, what would be the obvious thing we see? Muscle wasting, or the scientific word sarcopenia. And doctors are giving them huge amount of sugary amino acid to do this. Yes, there's a place for amino acid to make protein. You need GG. It's like a hook on the cell. And as the cell makes the protein, when it finishes making the protein, the GG, which is a hook, unlatch, and the protein is delivered. It's a big molecule. Without GG, the protein is made in space and is in the space of the cell and is not able to deliver to the site. And with that, we have difficulty making proper protein as we age because we don't have enough GG. Thereby, we have muscle wasting and sarcopenia. Simplistically, we say that you're not exercising your muscle, therefore you don't have a muscle making. Correct also, when you stimulate physical movement, you continue to make more GG. So it's the second one. The third one, MK4, which I already elaborated, that one has a beautiful story. All of us take vitamin K1 to green leafy vegetable. It's called phyloquinone. It has a ring and also a tail. They all look like this on this lipid material. And the ring is called a phyloquinone and green leafy vegetable. You notice that when you take this phyloquinone, people worry, don't take too much vitamin K because you clot. And when you clot, you just clot to death. If people believe that in its entirety, just let me walk through this with you. If I were to be a vegetarian or a vegan to be extreme, I only eat vegetable, my whole body would clot to death because I'll be consuming way too much phyloquinone. That is not correct, Ivor. So what happened? Our body is more beautiful than we think. It has a homeostasis. So now I'm giving you the real thing. When you take lots and lots of vegetable, like the cow only eat grass, they would have clot to death. But the cow don't clot to death, They don't eat meat. So when we have this right in the intestine, the moment we have enough of the phyloquinone, vitamin K1, the clotting, when we need that, go into your body, into your system. Whatever we don't need, immediately we have scissors, enzyme, they cut it off. So you cut the tail off. And when you did, the tail of a vitamin K1 not absorbed, it's passed out. Surprisingly, the ring of vitamin K1, it absorbed. When the ring absorbed, we call them vitamin K3. Normal folks don't call it, scientists call it. But so K1 is cropped off, K3 went in, just the ring. When it go in, I am so grateful. This is entirely explained by Japanese scientists in the last 10, 15 years. It's not a long time ago. If you hear it for the first time, it's okay. You hear it in your show and so it's published like that. And you know what they did? The moment K3, which is ring, went in, it looked in at least 25 places in your human body. It desperately looked for a GG molecule. It looked for the GG molecule to stitch onto the ring. I just explained simply to you, that's MK4. That's it. So in other words, our body learned through its evolution of time to preserve the ring K3, go in and make MK4. So it begged to ask the question, why does the human body singularly only make one manoquinone, and that manoquinone is MK4? I hope in the next 10, 20 years, while I have still passion in my life to study, as I do this, I would love to deliver. Until then, I can say this. If we don't have enough GG as we age, it's not making MK4. Currently in Japan, there are 3 reasons why people take MK4. Some of them already as a drug. One, it helped to prevent arteriosclerosis in the artery, MK4. 2, it helped to reduce severe inflammation, and they study it with people with rheumatoid arthritis or or osteoarthritis. And the third one, it helped postmenopausal women not to have osteoporosis, kind of sounding like MK7. It does a similar thing, except this is using your own body's ability to make MK4, and that is done through GG in your body. So if over time our drop in GG, it would also mean drop in MK4, as it's making muscle, as it's making CoQ10. Sorry, I took too long to explain that.
No, I think that's perfect because I could follow it absolutely fine, which means most people can. But no, that's fascinating. So the GG, I love that whole answering some of these open questions on the K2 and even K1. So the K1, just to get this parsed out, the K1, when you take too much of it, the body is smart, of course. The enzymes clip the tail off K1 so you don't have too much K1 and too much tendency to clotting. And it's homeostasis and it just balances it. Absolutely makes sense. But then the tail chopped off, you still take the ring of K1 inside because that's essentially substrate combined with GG to make MK4, which has its own uses. And I wasn't aware at all of that. And just one clarification, without the K1 ring, presumably your body can still make MK4 through other mechanisms. Like it doesn't need the K1 ring substrate, absolutely. It just can avail of it.
Okay, you use a beautiful phrase. I was trying to avoid because I did not know if the audience would know. Yes, vitamin K1, the ring become a substrate to making MK4. Then your follow-up question would be that, do we need the ring? Into this question, yes. I don't know why certain rings in the body can make, such as CoQ10 has a ring also. It make the ring and the super long tail. CoQ10 is a very, very long one, longer than anything else that I know. And the whole body makes it. Shocking and surprising to me. But when it comes to the ring of vitamin MK4, which is also the ring for phyloquinone. That's why they are part of the vitamin K family of compound that you can only get from plant. So if we stop eating green leafy vegetable, then we would not have enough of the ring. The ring has to be gotten from outside. The body does not produce the ring for the vitamin K, which is why vitamin K is a vitamin. A body cannot make it. It had to be gotten from outside. But at the time when that was discovered, two scientists, a Danish gentleman and an American gentleman, got the Nobel Prize for their discovery in the 90s. I'm always fascinated why people get Nobel Prizes, just to have that on. So, but that's only for K1, so that it helps people to clot properly. When you have a tear in your artery, you want it to clot. You don't want to internally bleed to death. We want it to clot, Of course, the opposite can happen. If our blood gets too thick, you got to figure out a way to thin your blood, something like that. So this is always the balance. So the vitamin K provides the clotting factor. However, the menaquinone did not have the clotting factor. The MK4, I just use a simplistic explanation again. You use the vitamin K sets of compound, make a protein. I'll just use a scientific word you don't have to memorize. It's called glutarate carboxylation protein. They use glutamic acid, they carboxylize them, and with that, a protein is formed. And that is a very specific protein, and only the vitamin K family can do this. And when the vitamin K is K1, when that protein is made, it helps in the clotting. When that is MK4, which is another vitamin K, when that happens, that protein also forms. When that protein forms, it will be a chaperone. It holds the calcium and delivers the calcium to the bone, and hence it helps to prevent osteoporosis, particularly postmenopausal women. then that protein is formed. It also not deposit in soft tissue, like the few that I mentioned to you in the gallbladder. Anybody who have gallstone, they would know what I mean. It's painful. Anybody who have kidney stone, they would know what I mean. It's not good. And anybody who have arteriosclerosis, the doctor will tell them, those are the places the calcium is put in the wrong place, and the vitamin K4 can assist in them. So that's I'm hoping the audience will get this. If you got this, you are a light year ahead of other people on understanding, and then you can pass the information to them. And I'm going to send you all this information, but if you want to know beforehand, you simply type manoquinone for Japanese study. You'll get all the studies yourself.
Excellent, yeah, and we have a lot of listeners too who do love to go and see the studies themselves, and I often try and attach them. And actually, some people watching may be familiar with what you described there as matrix GLA protein is another kind of name it goes under, and that'll resonate because there was some Weston Price and various people who are enthusiasts about K2 have talked quite a bit about matrix GLA protein and carboxylating it and enabling it and all that kind of stuff. So there'll be some who are a little familiar, but not in the whole tapestry that we're describing. You're filling in a lot of the gaps here. Now, I wonder, so the K1 ring is required. We can't actually make that ring, but we can turn it into MK4 using GG. So that's very interesting. And there are precedents that, for instance, vitamin C we can no longer make. We must get it from the outside world. Like you say, it's a vitamin. But I wonder, if you have very few plants, we know there are a lot of people around the world now, including doctors and surgeons and high profile people who have gone carnivore, right? Now, we won't discuss, that's a controversial one, but they seem to be doing really well because they seem to be getting all they need from eating meats and organ meats. So I guess they're getting the K2 and whatever's needed for GG via the meat world, you know, from other animals. That has to be the case, I guess.
That I have not thought of that. I had heard of the carnivore diet like that, and I understand that it's controversial. I'm more like an omnivore like that. I think the world have changed. We are not like the Neanderthal where we are just out there hunter-gatherer. We're simply not able to live life. If I were to be the world's strongest man or doing some ninja this and that like that, then I'm physically active or I'm a super football player, but I'm simply not like that. So that would be, you need a lot of energy to help. But I tend, like you, we're sitting in front of a computer doing a lot of mental work. So it needs to be a balance. But for what it's worth, people who entirely go carnivorous diet or people who entirely vegan diet, they have their pros and cons. If you were to eat organ meat, you would tend to have more CoQ10 because CoQ10 are in the organ meat, dark meat to be specific. You'll probably get a lot of MK4. You would probably get a lot of heme because it will have a lot of iron to be bioavailable, or the plus. With that, you're also going to get a lot of cholesterol. For whether you believe it or not, you're simply going to have a lot of cholesterol. Besides your human body, when you grow old, they produce extra amount of cholesterol. So it's something having to do with the liver, because most of the cholesterol is produced in the liver. So whether we accept it or not.
Oh, I was just going to ask, yeah. Oh no, the whole cholesterol thing, yeah, we've been through for years, so I agree. There's no need to go too deep into that. But just in principle, I guess, if you have very little plant food, I guess you're getting the nutrients like MK4 directly from the animals who they themselves had it, or CoQ10. So it just shows the adaptability of humans that if you're mostly only getting in late autumn or winter in Northern Europe, mostly only getting meat, you're going to get what you need. And then if you have to depend more on vegetable foods, you've got the synthesis machinery to make what you need also. So it's adaptability, I guess.
Yeah, it's adapted. Yeah, and actually, while you're on this, I think this is a perfect time for me to say this. Philosophically, I didn't say this at the beginning. but this is a very interesting concept. This molecule, which is GG, like that here, and we took some time to explain what we get from the plant and what we get from the animal, cholesterol, MK4 and K1 like this. In the history of GG, in the US, we are fixated with having muscle distress, and GG helps. And the muscle distress is right on our face because of the statin taking problem. In Japan, they are interested in GG, but they're interested in GG as a building block. And I mentioned to you the few building blocks of CoQ10, MK4. They're interested in just how GG can work in the human body. That's Japan. And then in EU and the US, they're beginning to be very interested, independent of myopathy. Why and how does GG mix protein when GG itself is not an amino acid? So that is beginning to capture interest. That's the scientist thing. Let me add on a nuance to enable and empower our listener. In the plant kingdom, we have GG. Notice how I said it? I'm changing the subject now. In the plant kingdom and GG, how can I validate that the plant kingdom have GG? Well, for one thing, I discovered GG in annatto. It's from the plant, right? It's in the process of using it to make tocotrienol like this. But I have a simpler answer to the question I just raised. If you eat vegetable, or in the fall, in the autumn in Massachusetts, here in beautiful New England, now it's not so beautiful, it's full of snow, but in the fall, people brag that New England have fantastic foliage color. It does. And the foliage color is an array of carotenoids and carotene. All carotene, which is 40 carbon, is well known. 40 carbon is 20 carbon and 20 carbon. A reaction come together, and then they're 40 carbon. 20 carbon is GG. So two GG molecule come together and become carotenoid. Therefore, this to say all the carotenoid, the one that you and I know because we are so fixated in the human health, lutein, zeaxanthin, lycopene, astaxanthin, they came from GG. Besides all this, there are 600-700 carotenoids we never heard of. They came from GG. That's one. When we look at plant, usually we think green, chlorophyll. Chlorophyll came from the synthesis of GG. Plant again. And then let me say another one. And with this, right, you have your attention and my attention have to be arrested with GG, please, because you think of phytonutrient. Almost all phytonutrient came from GG. So all this to say, in the plant kingdom and in the animal kingdom, GG is the last common step between the two in synthesis. And now, after all these decades, we now hear of this. I'm speaking of, if I had spoken this earlier, Ivor, I am creating a pent-up vacuum in an audience. Well, Dr. Tan say all this. There isn't any GG around. When you eat vegetable, it had already converted to carotene. Very few vegetables have GG. And when you eat a normal diet, you perhaps can get about 2 to 5 milligrams of GG. And then when you eat vitamin K1, it depends on your own body GG to make it. And if you decrease in GG, then you have fine sources of it. And I'll just show you this, and you look at this here. The top here is GG molecule. And then I pull back the green color, example of carotenoid. The red color, because I'm just using that as a metaphor for heme. It makes CoQ10 and vitamin K4. You follow that? The molecule of GG is entirely embedded into the structure. When you have something like that, Ivor, you cannot wiggle out of it. It is part of the DNA and the structure. So if it's part of that, if you remove the GG, the plant cannot make it. In fact, there are companies who spray pesticide, they spray it, they stifle the ability of making GG, and then they exfoliate and defoliate the color, and the plant die. Doesn't that tell you something that GG is essential? And the Japanese are now studying it. Besides all this that I mentioned, they're studying other GG compounds. What do I mean by that? So then I'm not now talking about MK4, CoQ10, we already know this. Other GG compounds are Geranylgeraniol acetone, Geranylgeraniol carboxylate acid, and the third one from Stanford and UC Berkeley, GGG, Geranylgeraniol glutathione. And people know about glutathione. So the body find the GG and attach to glutathione. My God. So there's so many things I don't even know about. So that means that the human body is using the GG that we make to make other GG-like compound for which we don't know. So far, we only know one thing. The GG carboxylic acid, if the body does not make it, the embryo will not get to full term. And when the baby is born, they do not live more than 2 months. That to say, Ivor, GG is required for growth and survival. We know so little about that. You just Google. Trust me, I do not like to live life a lie. You just put Geranylgeraniol carboxylate acid, you see the Japanese publish it. If you put Geranylgeraniol glutathione, the Berkeley or Stanford professor, they say that without the GGG, then we are more prone to oxidative damage, probably from the glutathione, oxidative damage, and will be more prone to cancer formation. And this is still in the early stages of study. I don't know where they are going to go with it, but that have to do with GG, some other product not recognizable, like CoQ10 and MK4. And all this is quietly, endogenously made in the human body. We don't know because no Nobel Prize people have gotten it yet. The moment they got it, then the world would know. But at least I'm telling you and your audience, you can now search because the internet is allowing us such capability. So I am so happy, you know, if God gave me another 10 years, I will dig more into this and then tell you more about this.
Yeah, and we'll certainly be back to talk about it in more depth the more you discover, Dr. Tan, for sure. But that's amazing. So this GG, there's a universality to it, even between the plant and animal world, as you say, a common kind of root. And it's amazing you mentioned glutathione there, because I first got into the whole health sphere back in 2012. And the reason I got into it, one of the big reasons, was I had high gamma glutamyl transferase, GGT, which of course indicates a deficit in glutathione, which is the body's master antioxidant. And I remember making the point that your endogenous antioxidants and components are going to be more powerful than trying to take them in. But by all means, you can support them by taking in components. So I guess maximizing GG, actually, that brings me to a question, because people always ask this. Okay, we know indirectly that by not taking drugs that are problematic, by living healthily and getting lots of nutrition, and by doing all of that, you're going to maximize your body's natural antioxidants and crucial components. Healthy lifestyle and diet, that's okay. But in terms of optimizing GG through external or exogenous assistance, I wonder, does the tocotrienols coming in with the GG in the tail, does that bring in GG in a sense? Or what are other ways to boost?
Okay, an excellent question. Right now, we know that if you take tocotrienol, even though the whole molecule of GG is attached to the tocotrienol, it doesn't break that up. Unlike the vitamin K2 story, it doesn't break up and give you the GG. Instead, when you take tocotrienol, the body have ability to cut the tail piece by piece off like that, so that it would, that's the tocotrienol. But with the vitamin K is, so it's in I'm just using it, but don't take it wrong. In the vitamin K story, the GG adding on is an anabolism. It adds on. In the tocotrienol, it's catabolism. It cuts off. So I don't know why. Sometimes the body have wisdom. I'm just playing catch up to learn that. So that's that part. I do know that in right now we have done many at a cell line study, like on a petri dish, test tube study, and animal study. We are certainly able to confirm, as other institution and university have confirmed. We clearly address the one that is most obvious to us because of the huge number of people taking statin. Right now in the US, it's about 40 million. The American Diabetes Association asked diabetic, which is another 35 million people, to take statin. Like that. I'm not saying that our audience should be, they're pushing in that direction. And about 2 months ago, they studied statin in people who are 75 years and older. Why did they do the study? Because when they studied them in cholesterol reduction, these older age people were not part of the recruit because they fear they were too old. They were older and may have problem when they took the statin drug. Right now, the statin drug is established to lower cholesterol. So the VA hospital and Harvard University deliberately decided to study the elderly population. So it's a huge 10-year study published in Journal of the American Medical Association. Two findings. When they take statin, I know the audience may be against me on this, but I'm just telling you the finding. I'm not pushing anything. When they take the statin drug, they're 20% less in cardiovascular death of people who are beginning at 75 years old, and 25% of them have all-cause mortality, suggesting that statin have other pleiotropic property besides just cholesterol lowering. With that, I suspect the American Heart Association will probably suggest that elderly folks to take it. All this to say is moving in a direction that probably statin in the US, because it's already so inexpensive, will become the most popular drug taken. It will probably rival in the US Tylenol. Tylenol in the US is acetaminophen, and in Europe and England it's called paracetamol. So when you take paracetamol, is what we in the US we call acetaminophen, and the trademark is Tylenol here. When they do that, what does that mean? That means that the decimation of GG will become systemic because of the huge number of people taking statin. So we did animal study and showed it. And the study I like to quote is an Australian study just published in 2020. Ask Keith for this. I would love to send you that paper. This Australian group did this. They have a control group. They have a group that just give them GG. And they have the group that give them statin plus GG. They are mutually exclusive group. And in the control group, everything normal. In the group that with statin and GG, oh no, there is another group, just statin, 4 groups. Control, statin, GG, and GG and statin. And in the control group, just as a control, on the statin group, they saw muscle damage. And also they saw that the muscle hind leg ability to kick is less. So because of the damaged muscle. And then in the group with the GG and the statin, they're able to recover that group. They also study the heart muscle, and the heart muscle is strengthened. And then in the GG group by itself, not because of statin, they're able to increase the muscle strength also. So for that, it had benefit for the GG by itself, as well as the GG able to arrest the damage caused by the statin. And we translate the animal dose to human translation. So a normal 60, 70 kg person will be approximately 150 milligram per day. It's not a huge dose. So I got, and then other people have done. So here, I know you're going to ask me, so I preempt the question. So how much is necessary, this and that? If you take a normal food and diet, say if you don't eat a lot of organ meat or dark meat, probably about 5 milligram or less. If you tend to eat a lot of red meat and organ meat, it's possible that you can get about 10 milligram or so. And from this study and other studies, approximately 150 milligram would help in statin mitigation, or as we go older, to help us in the support of our body in making muscle or skeletal protein, CoQ10, MK4 as we age. We internally, because we plan to do this, so we have the burden. We are not making any money fast, and we care for the health of people. We already done a 2-year study. Ivor, you are the first to hear this on the show. We've done 2-year study on toxicological and safety study, extensive toxicological and safety study. And that's only to answer the FDA. Is it safe or is it not safe? Not does it do blah, blah, and other blah, blah. Just is it safe? And we found out that it will do no problem on safety issue for a normal adult up to 500 milligram. Using some kind of formula the FDA say you must follow. If you do the scientific thing, it's probably safe until 1 gram. But if you use the formula the FDA say you must do this, you must divide this, so it's partly arbitrary, then we come up with a number 500 milligram. And now, happily to announce, when we did the animal study, 150 milligram will do just fine, which is 3 or 4 times less than the safe amount by the FDA. So I am thrilled to present this. I'm thrilled that Keith said that this is a good time to talk about this. So anyway, I guess I preempted the question about how much is needed, how much we get from food and food not supplemented. So
that's excellent, because that's always the question on everyone's lips, and I'm well aware of it now. And 5 or 10 milligrams from food, and I guess endogenous production will vary hugely, especially as you get older. So 150 milligram is kind of the coverall amount that probably reaches a plateau of benefit, is way below toxicity, and it makes sense for a natural endogenous kind of element. It's like with vitamin D. They say, oh, don't take more than 4,000 IUs a day, but we make around 20,000 IUs in the sun in half an hour in a bathing suit at noon. So you kind of know there's a very limited toxicology to lots of these inherently natural things. But that 150 milligrams nominally, and is that extracted from your tocotrienols or through a completely separate process?
Similar process. As I said in the beginning, after I got this seed here, which is hard to see from the thing here, the seed here, I remove all the oil, remove the color, and then I extracted the tocotrienol. Then I have this thing kind of like corn oil color, a little bit brownish, not exactly as dark as olive oil. I could not remove it. I didn't know what it was. So when I did, so we did chemical analysis, and when we did, we found out that this molecule GG, this is 20 something years ago. At the time, I have very few things to hold on to. I don't know what it is. And I said, well, let's keep it around. And I must say, sadly, and at least responsibly, but sadly, most of those earlier days, I throw all of this away because I didn't know what to do with it. And then in the last 10 years, so therefore, the audience should know, I did not keep this aside and cash it. I just do it because I didn't know what to do. And then in the last 10 years, we aggressively did study on it. We purified them. Our GG typically now is 75%. So how do we process it? I believed I should owe to the audience to do this. We never use chemical processes. We never use synthetic solvent, synthetic chemical. We use an entirely physical process by evaporation, by distillation, physical, entirely physical. So I did this through the encouragement of my wife, which I'm grateful like that. But it took me 5 years longer, just because she asked me, said, Barrie, you are privileged given by God to allow you to discover this from annatto. And now you quickly use chemical harsh method to get what you want. How about figuring out a way to do this that's not harsh, that's not chemical, and not use all this horrible chemical to do it? So I just said, and then it just stopped me on my tracks. I said to my wife, Elizabeth, I said, I got to think about how to do this. So over the years, I figured out that I can do it by distillation, evaporation. So therefore today, both the GG and the tocotrienol is a fine dance how I do this, to do it surgically, to physically separate them to entirely physical method. So if you were to get this material from us, I think Keith calls it GG Gold. And then the tocotrienol Delta Gold. You can, then it originated from us. We call it gold because we produce it in a pristine manner. I owe it to the public to return to them. So it never touched, when it got sent to us, we never touch anything with chemical in it. We only use rice bran oil, which is a beautiful oil, sometimes olive oil, just to use it for the evaporation as a lubricant to encourage it. So there may be traces of rice bran oil, but beyond that, no other chemicals do we use. So I'm exceedingly happy about them like that. And I personally take the GG. I take the GG, and this is not pushing anything, I'm just explaining to you. I take the tocotrienol about 300 milligram a day. Why do I take 300 milligram a day? If it's for antioxidant protection, I'll take probably half of that 150 milligram. I take 300 because I have genetic hypercholesterolemia. So I take that to prevent my LDL cholesterol from not getting oxidized LDL cholesterol. So that's the tocotrienol side. On the GG side, I'm in my 60s. I can do with some help in leveling my CoQ10, my MK4, and as I go older, I notice that my muscle tone is not the same as when I was younger. So I take the GG of 125 milligram, like that. I take them in a combination with CoQ10. We have a product here called duoquinol, where the GG is added to the ubiquinol. The ubiquinol is the active form. So when you take that, it does have the both of them. CoQ10 would be for the energetics, and the GG would be for all the other things I mentioned. So I take them, they come in. So I do not take CoQ10 and GG separately. It come already mixed because dual, because GG also is able to use in the body to synthesize CoQ10, and also added a little bit more CoQ10 as well. But we don't have a product with GG with MK4. We don't have that. There is other people make product MK4 with vitamin D, as you mentioned. We don't, because we don't make MK4. Neither do we make vitamin D. People can openly get that accessible, but GG is what I'm trying to bring forth to see what it can do. So those are the personal examples of what I take.
Yeah, no, that sounds great. And again, you can only use the scientific knowledge and all the work that's been done out there to try and come with a best formulation of anything. And interestingly, I often point out to people that the pharmaceuticals all largely come from the plant world, but often they're synthetic molecules that are remade to be patented, and that calls into question a lot of their properties. Whereas to take beneficial molecules that line up with human physiology but boost your own natural health from the plant world makes a lot more sense to me if you want to go that direction. So that's fantastic, Barry. And oh, our mutual friend, of course, Warren Matthews in New Zealand. I'm sure he's going to be fascinated by this emerging new data also.
Wow. Yes, I'm very, and now that you mentioned about the pharmaceutical company, I'm embarrassed to say when I searched the literature, apparently the pharmaceutical company knew as early as 1989, 1990, that's a long time ago, that when you take statin drug, the body will decimate GG. And in the decimation of GG by statin, myopathy is going to happen. But it's buried. And even to this day, even very literate scientists are not saying this in our nutritional supplement industry. And now I'm saying this. I like to show you a history of GG. I know that this is too much. I like to send this to you, but you can get a picture. You see the advent of a statin thing on the end there going up. And then if you
Yeah.
look at the earlier years, Leopold Rizika, in the 1939, he got the Nobel Prize for synthesizing GG. For the good life of me, I did not know why he was synthesizing GG. So if you look again, 1939, a Croatian Swiss person synthesized it, and then the Nobel Prize was given for LDL receptor. And then 1978, I pencil it in, the Peter Mitchell for CoQ10. And then all the different things when people start taking statin. I think this GG thing, it need to be there now so that to finish up all the understanding, the gaps in the understanding. I hope I presented to the audience the understanding that GG fills the gap of understanding MK4. GG fills the gap of understanding of CoQ10. In other words, if you take statin drug, they drop GG, voila. That's why CoQ10 drop. Because you zap all the entire tail of how CoQ10 is made. But most audience does not know yet because the publication is just coming out that when you take statin drug, you saw the manifestation of MK4. They don't connect the dot. They only know that if they take statin drug, hey, the calcium is put in the wrong place. Hey, the calcium is not in the bone. The reason the calcium is not in any of those places or put in the wrong place is because they zap the GG and the GG is not able to stick it into the tail of the vitamin K. So MK4 is not made properly. And without the MK4 made properly, the carboxylated GLA protein is not made. And when that is not made, problem happen. So if you trace back, right, trace back bone problem, trace back to the GLA carboxylation, please follow me on this because the alternative, you're not, you're just zoning in on like grabbing the thing, like the three blind person. Oh, this is the leg of an elephant. This is trunk of a tree, like that. But the story connect. Osteoporosis, bone not having problem. The reason is because of the carboxylated GLA. Don't stop there. The carboxylation of the GLA is because you don't have MK4. And why don't you have enough MK4? You don't have enough GG. Trust me.
Yeah.
It is like that. So once you get that, then you got it.
Well, no, that's a perfect articulation of the overall picture to draw to a close, Barry, and it's fantastic. And it fills a lot of gaps for people who will have some familiarity with various aspects of this, but certainly not be able to go back to the root. For me, in a sense, it's like a root cause analysis. You know, you've got to go back through all the pathways, and there are many loops where things are affecting other things and back affecting. But this GG seems to be a real nexus that connects together so much. So a fascinating story indeed, and it'll be great to get it out there. And like you say, we might put in some links. I'll have the high definition pictures of what you held up and some links to some various papers so people can go and do some more further study themselves, which is fantastic.
Yeah. Let me give you a last line to attach to what you just said. You mentioned the root cause. The root cause is because the roadmap of GG was never in the picture. So now that the GG is in the roadmap to answer the root cause, then the reason is because GG is the building block. So now when we understand that GG is a building block, we go back to the very beginning of our interview. They say that, not surprisingly, whereas tocotrienol is an excellent molecule to protect antioxidant protection, it is the dog. And finally, we have the opportunity now to explain the tail, which is the GG, is now wagging the dog. So thank you so much for allowing me to do this. Hopefully, when you post this, if your audience have questions, you can go to barrie10.com. Right now, I don't have a book on GG written. I only have the book on vitamin E, which your folks have. You can download this. I only do this as a labor of love. So if I'm pressed enough by my wife and other people, I probably will write a book on GG and put all of this in and encapsulate. So right now I haven't had that. So if you have question though, send to me or put on the link. I will gladly put out the papers that I have on GG. So I thank you to you for allowing me the time to do this. I'm grateful, and also to allow your audience to expose to this. And as they have questions, then they could ask us. And by the way, if the audience themselves have unique find on GG, I'm not the final arbitrator of truth, you know. If you find something good, please send to me, because it may stimulate me to do even more search and more industrious to bear out information. So thank you once again. Keep safe and be well.
Thanks so much, Dr. Tan, Barry, and your last words there, spoken as a true scientist, always open to emerging data, new data, and that's the way we all need to be. So I'll put those links there and people can send their questions on, like you say. All the resources will be there, and it's an absolutely fascinating story. So hugely grateful that you took the time today to share it with me and with everyone out there. Thank you.
Thank you. Have a good day. Blessing.